Okay, algebraic modelling is the next chapter. Algebra is used to model problems found in the real world. So what we need to do with an algebraic problem is first find the unknowns, assign them to variables, and then work equations out that model the situation. Once a rule is created, we can use them. Okay, so here are some basic situations and some basic equations, and then we're going to go through one that's much more complicated at the other end of the spectrum. So if the total cost of we want to find the total cost of K bottles if each bottle costs $4. So K is our unknown. We don't know what K is. Here's K here. K is our unknown. All we know is the bottles cost $4. So the total cost will be the number of bottles times by $4. So the number of bottles times $4, which gives us 4K. We've let K equal the number of bottles, and then to find the cost, it's $4 times by the number of bottles, which was just 4 times K. Alright, number 1 done. Second case, the area of a rectangle if the width is 2 more than its length, and the length is x centimeters. So the unknown it's told us is x, and it's the length. So why have I put width there? So let's go fix that up. I've got these back to front. Fix that up. So x equals the width. It's not right either. Better get it right eventually. The width equals the length. There we go. Plus 2. So let x equal the length, because that's what it's told us up here. Now, wherever we've got length, we're going to put x. So I've done that there. So the width is equal to x plus 2. Now, it wants the area of a rectangle. Well, the area of a rectangle we know is length times width. So if we know the length is, this is still back to front. Didn't do a very good job of this, did I? Let's rub that out. The length is x times by the width, which is x plus 2. And this is an expanding the bracket problem. X times x is x squared. X times 2 is 2x. And that gives us the area of a rectangle if the width is 2 more than the length. Right, so part C. Total cost of hiring a plumber for n hours if he charges $40 call-out fee and $70 per hour. Well, the unknown is n. We've been given it, so let n equal hours on the job. The call-out's charged once and $70 for every hour that it works. So here's the call-out. And $70 times by every hour that they've worked, which gives us an equation of 40 plus 70n. Page 1 done. Let's go to the next page. This one's a bit more complicated. It's a good one though. I like it. So here, Alwyn can pay $50 to go on older rides. Bryson can enter for $20 and pay $2 per ride. Calvin can enter at no cost and pay $5 per ride. Which has the best deal? Now this is more complicated than it looks because the best deal depends on how many rides they go on. Let's see if we can find out why. So the first thing we have to do is identify the unknown. The unknown we're going to call x, and that's going to be how many rides they'll go on, because that's the thing that changes. So for A, Alwyn just pays $50. It doesn't matter how many rides he goes on. Bryson, which I've called B, he pays $20 up front and then $2 per ride. So if he rides once, it'll be 2 times 1. If he rides 50 times, it'll be 2 times 50 plus an additional 20. And Calvin enters for no cost, so he's got no fixed cost up front. And then he pays $5 per ride. So $5 times 1 would be $5. If you did 10 rides, it would be 5 times 10 is 50. Now that we have some equations, we want to make a conclusion. Now later in the year, I'll show you a different way of working this out, but for now we don't have a lot of solving ability, so we're just going to have to do a bit of trial and error. So let's look at A and B. So if A is 50, when is B better than A? Well, if it only goes on one ride, B will be charged $22, but A would be charged 50, Alvin would be charged 50. So B is significantly better. But we're looking at when does A become better than B? So that would be when, for the same number of rides, B costs more. So 20 plus 30 would be 50. So for this to be 30, X would have to be 15. So after 15 rides, A becomes better because it would have cost more under the Bryson formula. Now let's look, when is A better than C? Well, if he did 10 rides, 5 times 10 would be 50. So any more than 10 rides, Calvin would be paying more than Alvin. 10 5s are 50. Oh, there's a problem in my equation here. Why did I say 25? Let's fix it up. A is better than C if A is greater than, if X is greater than 10. No, that's not right. A is better than C. Yeah, if X is greater than 10, that's right. So more than 10, A becomes the cheaper scenario. Now, let's go around this the other way. So C is better than 10. C is better than A when X is less than 10. Yep, got that here. Because if X was 9, this would be 45 and that would be 50. C is better than B. This one's a bit harder, isn't it? Let's try 5. 5 5s are 25. 20 times 30. Yep, 5's okay. Let's try 6. 12 times 20 plus 12 is 32. 5 times 6 is 30. No, that's still better. So I'm guessing it's 7. So as long as X is less than 7, 7 is better than B. Now let's check when B is better than A. Well, for B to be better than A, this would have to be less than 30, so X would have to be less than 15. Yep, I agree with that. B is better than C when X is greater than 7. So, well, what did I say that for? Let's see. Well, 7 5s are 35. 2 7s are 14. That would be 34. Does sound about right. So, if X is greater than 7, then B is better than C. Because if we did 8, 8 5s are 40, and B is 36. B is still better. If we go on the other side, X equals 6, 2 6s are 12, 32. This would only cost 30. No, that's right. So now we have to see when A, B, and C is best. Well, if X is greater than 15, A is the best solution because these become bigger, and this becomes bigger than 50. Between 7 and 15, B is better. And between 0 and 7, C is better. There you go. And if you're not quite sure of that, you can go and test it by just putting in values of X into the 3 equations and seeing which one costs more. Now, as I say, we will come better at this part later on when we can solve equations, but for now, with a bit of trial and error, we can still get to somewhat of a solution. Thanks, guys.